Hello everyone. So this is a question from JEE Mains 2026 28 Jan evening. Two positively charged particles M1 and M2 have been accelerated across the same potential difference of 200 kilo electron volt as shown below. Okay. So let us mark the important points. That is, we have two positively charged particles of mass M1 and M2, and they have been accelerated across the same potential difference of 200 kilo electron volt as shown below. Now this is the diagram of a discharge tube about which we will discuss, and mass of M1 again is given to us as 1 atomic mass unit, and mass of M2 is given to us as 4 atomic mass unit. Important information. Okay, the de Broglie's wavelength of M1 will be x times of M2. The value of x is, so basically we are supposed to find the de Broglie's wavelength. Okay, so the chapters involved is atomic structure, and as I said, this is a discharge tube which is given to us. So a discharge tube is similar to a electrolytic cell, where we use external power supply or external voltage to drive the particles from a particular end to another particular end. In this case we have positively charged particles, so that's why they are attracted towards the negative charge plate. Okay, and using this discharge tube itself we have discovered particles like electrons and protons. Okay, now obviously in a electrolytic cell or in a discharge tube, the anode is going to be positive, so this is the anode and this is the cathode. Okay, and since they are positively charged, so they are attracted towards the negative plate. Okay, now coming back to de Broglie's equation. So we know that according to de Broglie, according to de Broglie's equation, the de Broglie wavelength, that is lambda, is equal to h by mv. Okay, where h is our Planck's constant, m is the mass of the material particle, v is the velocity of the material particle, and obviously lambda is the wavelength of every matter or material particle. So according to de Broglie, he said that even macroscopic particles will have wavelength associated, will have some wave character associated with it. So using this formula we can calculate the wavelength of a material particle. So this is h by mv. Okay, in this question, so we don't have the velocity of the particles. Okay, we don't know the value of velocity of the particles, and so therefore but one information is given to us that they are accelerated by a potential difference of 200 kilo electron volts. Okay, so we know that the de Broglie's wavelength of electron can be calculated even from the potential applied to accelerator. Okay, so let us say that the accelerating potential, that is the external potential that we have applied to accelerate these particles from one end to another end, so let us say that that is v. So the accelerating potential or the external potential that we have applied is, let us say, that is v in volts, and let us say that this potential is applied to charged particles and the charge carried by them is q. Okay, so is applied to charged particle carrying charge q, right? So obviously since they are accelerated by potential v and they carry charge q, so the energy acquired by the charged particle, energy acquired by the charged particle when it is accelerated through potential V and carrying charge Q will be obviously the product of charge into the potential difference, yeah, potential applied, right? So it is going to be Q in coulombs into V, that is the potential in volts, right? And so this is the energy of the charged particle, and this energy will ultimately become the kinetic energy of the electron, right? So this energy is nothing but, so this energy, because of the potential, this becomes the, or this is equal to the kinetic energy of the charged particle. Okay, so therefore, okay, so now we know that kinetic energy is equal to half mv square. Okay, and as I said, we don't know any information about the velocity, right? We know that lambda is equal to h by mv, and in this equation we don't know what is the velocity of these particles, so that's why I will try to get this kinetic energy with respect to v and substitute the value of this v here. Okay, so I will get 2 into ke divided by m square root is equal to my velocity, right? So I got the value of velocity with respect to kinetic energy and mass, and I can substitute this here. So therefore de Broglie wavelength will ultimately become h by m into root of 2 ke and root of m in the numerator. This m can be written as h into root m divided by root m into root m into root of 2 ke, or you can directly do the calculation. This is m to the power 1 by 2, this is m to the power 1, so cancel. So one more formula of lambda, that is h by root of 2 into m into ke, right? So this is one more formula of de Broglie's wavelength, where I mean it is equal to h by root of 2 into mass of the particle into kinetic energy of the particle. Here again we don't know the kinetic energy of those particles, but we did something. We wrote a statement that the energy acquired by the charged particle, because it is accelerated, that is q into v, will be equal to the kinetic energy of the charged particle. So I can write, instead of ke, I can write q into v. So lambda is equal to h by root of 2m q into v. So this is one more variation of our de Broglie's wavelength, and this is with respect to the applied potential. Okay, so this is one more variation. So remember this, whenever the mass and velocity, I mean whenever the velocity is not known, we can, and accelerating potential is known, this alternate formula to calculate de Broglie's wavelength can be used. Okay, and now in the question they have given us that m1 is equal to 1u and m2 is equal to 4u, and both are accelerated by same potential, that is 200 kilo electron volt. And assuming that both the particles have the same positive charge, because the charge that they carry is not mentioned, so I'm assuming that both particles have the same charge. Okay, otherwise this question cannot be solved. So both particles have same positive charge, they are positively charged, so they carry the same positive charge q. Okay, in that case, so if I want to find lambda 1 by lambda 2, so obviously this is for particle 1, de Broglie's wavelength for particle 1, this is for particle 2, and we got an equation with respect to the potential through which it is charged. So I will write this down here. So h by root of 2 m1 q into v divided by h by root of 2 m2 q into v. Okay, because h and h are same, the charges are same, and they're accelerated by the same potential v, so that's why it's the same. What's the difference in them? The difference is of the mass, which they carry. Okay, so I can write this lambda 1 by lambda 2 as, so h by root of 2qv into 1 by root of m1 divided by h by root of 2qv into 1 by root of m2. So this gets cancelled. So lambda 1 by lambda 2 is equal to root of m2 by m1, right? In the question, m2 is given to us as 4u, m1 is given to us as 1u, so it becomes 4 by 1. So therefore, upon solving, lambda 1 by lambda 2 is equal to 2. So therefore, lambda 1 is equal to 2 times of lambda 2, right? So therefore, the answer is going to be 2. So the de Broglie wavelength of m1 is x now times of m2, so the value of x is 2. Okay, thank you.